So now you can see that the pure resistive circuit. So it is not stored energy because it is a resistor. No energy is stored in that elementary circuit. So resist connected to the AC current. So R is the resistance. So V equal to Vm sin omega t at any set of time the voltage. So flow of current, we have to calculate the flow of current. So this is the voltage. V equal to Vm sin omega t. So V equal to IR according to Ohm's law. So here sin omega t, Vm sin omega t, and V is also V. Comparing these two equations, because V is there, so V equal to IR. So the equating that the flow of current I equal to Vm by R, or Vm by R instead of we can write Im means I equal to Im sin omega t. So Im sin omega t, Vm sin omega t. So there is no phase difference. ரெண்டுமே ஒமேகா டி தான் இருக்கு. அப்போ ரெண்டு நடுவில் ஃபேஸ் டிஃபரன்ஸ் கிடையாது. அப்போ the flow of current and voltage are in the same phase. There is no phase difference between the flow of current and the resistance. So voltage and current have the same phase, that is 0. So when the resistor is connected to the circuit, there is no phase difference produced. The flow of current and the resistance are in the same phase. அப்போ ஒரு ரெசிஸ்டர் கொண்டு போய் ஏசி சர்க்யூட்டை கனெக்ட் பண்ணோம் அப்படின்னா phase difference இருக்காது. Current to voltage same phase தான் இருக்கும். So when resistor is connected to the circuit, it producing the same phase. The peak value and that zero occurs in the same time period. Okay, so that's called a phasor diagram of pure resistive circuit. So it represents the delivery by the source in phase with the voltage. Right? So this is a phase and phase difference. There is no phase difference. Next thing, the AC circuit connected with inductor. So AC circuit la ஒரு resistance connect பண்ணோம். So now we are going to connect the inductor with the AC circuit. So AC circuit is a pure inductor. It connects the pure inductor. That inductor is a energy storage device, because you know that when the current flow through the inductor, it will store the energy in the form of magnetic field. So at any instant of time, that in voltage applied to the inductance L equal to L, this V equal to Vm sin omega t. அப்படின்றத சப்ஸ்டிட்யூட் பண்ணி what is the flow of current phase அப்படிங்கிறத நம்ம பார்ப்போம். So AC voltage applied to an inductor. See that. So consider a circuit containing a pure inductor only shown in the figure. Let us supply the alternating voltage E equal to E0 sin omega t. That is V equal to V0 sin omega t. So instead of V, they are writing the E and E0. So when the current is flowing through the inductance coil, a magnetic field is produced in the self-inductance coil. That is inductor. So it produces self-inductance also. Already we know that. When the current flow through the coil, it produces the magnetic field and self-inductance. So the magnetic field is produced. So E equal to L into di by dt. So from the self-inductance already we know that. So when the current flow through the circuit, it produces self-inductance. That E equal to L into di by dt, or E equal to E0 sin omega t L into di by dt, or di equal to L dt இந்த பக்கம் கொண்டு வந்துட்டோம். So di equal to E0 by L sin omega t dt. On integrating on both sides, because we need the current. So I is equal to E0 by L integral of sin omega t dt. So E0 L is a constant. Integrating that sin omega t dt, you will get minus cos omega t divided by omega plus constant. So I equal to E0 by L is a constant, and minus cos omega t plus omega plus constant. So after integrating that, you will get this value. So we can use the condition average value current over in complete cycle is 0, which gives K as 0. So that's why we are going to neglect that constant value. So now we are going to see that E0 by L0 cos omega t is there, but voltage in sine value, so we have to convert that cos theta into sine theta. So sine omega t minus pi by 2. So we can write cos omega t sin omega t minus pi by 2 அப்படின்னு எழுதலாம். So equation number 2, comparing that equation 1 and 2, see that equation. So E equal to E0 sin omega t is there, but here I equal to I0 instead of I0, E0 by L omega, that is I0. So I is equal to I0 sin omega t minus pi by 2. So we are going to write to that. So I equal to I0 sin omega t minus pi by 2. So there is a phase difference. Here current is lags behind the voltage by the phase angle of pi by 2. So from the equation voltage and current, we can see that that current lags behind the voltage by the phase angle of pi by 2. So voltage வந்து sin omega t இருந்தது, but current வந்து sin omega t minus pi by 2 அப்படின்னா, so current வந்து pi by 2 பின்னாடி இருக்கு. அப்போ when the inductor is connected to the AC circuit, that current lags behind the phase angle of pi by 2. So inductor circuitல current வந்து pi by 2 phase angle பின்னாடி இருக்கும். Okay. So pi by 2 phase angle பின்னாடி இருக்கும் அப்படி சொல்லிட்டோம். So resistance அப்படிங்கும்போது same phase, there is no phase difference, but when you connected the inductor, that the current lags behind the phase angle of pi by 2. So now we are going to see that AC circuit containing only a capacitor. So capacitor கொண்டு போய் connect பண்ணோம் அப்படின்னா என்ன இருக்கு அப்படின்றது இப்போ நம்ம பார்க்க போறோம். So introduction, application to the AC through a pure capacitors, right? So you see that in our home we have the fan. So when you switch on that fan will rotate. Suppose it will not rotate, means that capacitor has some problem. So all the fans has the capacitor. See the capacitor. So capacitor is inside that fan. So it is like a cylindrical shape. Inside is the fan. See that. So this is a capacitor. This is called capacitor, commercial capacitor. So capacitor has the two parallel plate. You know that it's separated by the small distance, and it is connected to the AC circuit. So that's a capacitor. The symbol of capacitor that is connected to the AC circuit. So when battery is connected to the two parallel plates, that is capacitor, charge can be flow from that battery to the two sheet, that is 1 and 2. Between that, dielectric medium is placed between the capacitor to increase the capacitance. So 1 and 2 are the two parallel plates of the capacitors. So Vm sin omega t is the applied voltage applied in the AC current. So any instant of time, that applied voltage equal to Vm sin omega t. So sin omega t is the phase angle of voltage. So that is applied to the battery. So battery negative terminal is connected to the plate 2, positive terminal is connected to the plate 1. Now when the battery is connected, so giving the alternate current to the parallel plates. So the two lines are connected to the parallel plate with the battery, positive and negative terminal. The negative terminal gives the electron to the plate 2. So what will happen? So that it is a capacitor is a storage device. It stores the energy in the form of electric field. So that will repel the positive charge and attract the negative charge. So the repelling negative charges are moving towards the positive terminal, and it is that circuit is continuously, that the positive electrons are moving from one plate to another plate, then repels the electrons. So that electrons are moved from that plate 1 to that battery. So the plate 1 become positive charge, plate 2 become negative charge. So positive charge is in that plate 1, negative charge on plate 2. So capacitor charged. So now that it acquires the maximum charge, so capacitor is charged. So now current is flow from the positive terminal to negative terminal when the capacitor is discharges. That current cannot flow through the capacitor, you know that. Only that it is converts that charge into electric field. It's stored in the form of electric field. So that is called display. In 5th lesson you studied that is displacement current. So it is stored in the form of electric field. So that now we are going to see the capacitance of the capacitor. Applied potential difference across the capacitor, we can take as Vc. So Vc is the capacitor. Potential difference across the capacitor. So Vc equal to Vm sin omega t. So Q is the charge on the plate. Q is the charge on the plate, and I is the capacitor current. I is the capacitor current. Now you see that Q equal to C into V. Already you know that. So C is equal to capacitance. V is the potential. So V equal to Vm sin omega t. So substitute that value in that equation. I is equal to rate of flow of charges. So I is equal to dq by dt. In the second lesson we learned that I is equal to dq by dt. Rate of change of flow of charges are called current. So I is equal to dq by dt. You substituting that q value. So q equal to you are substituting C into, instead of V, you are writing Vm sin omega t. So here we are going to differentiate this value. So I is equal to, so omega C into Vm sin omega t, that is differentiated, you will get cos omega t. So differentiating the sin omega t, you get cos omega t. So I is equal to Vm by 1 by omega c. So you can write 1 by omega c into cos omega t. So here also we have to convert that cos theta into sin theta. So cos theta equal to sin theta plus pi by 2. So Vm by 1 by omega c into sin omega t plus pi by 2. So again you are going to write that I is equal to the same format. I is equal to I0 sin omega t. That format, we have to convert that into the format. I is equal to Vm by Xc, where Xc is the capacitive reactance. That's called capacitive reactance. Plus omega t plus pi by 2. Then I is equal to Im sin omega t plus pi by 2. So Vm by Xc, you are instead of writing Im. Now you can compare that equation 7 and 2. Sin omega t plus pi by 2, but there sin omega t is there. So when the capacitor is connected to the circuit, that current leads the voltage by the phase angle of pi by 2. Current leads the voltage by the phase angle of pi by 2. அப்போ ரெசிஸ்டன்ஸ் இருந்தா ரெண்டுமே ஜீரோவா இருக்கும். இண்டக்டரா இருந்தா voltage leads the current by the phase angle of pi by 2. In capacitor, current leads the voltage by the phase angle of pi by 2. Okay, so this is the capacitance connected with the circuit, AC circuit. So it's a phase angle between the voltage and the current. So this is voltage and current. Yellow color line is the current. So 90 degree phase difference between these two is 90 degrees. That is pi by 2. So it's a phase difference between the voltage and the current. The current leads the voltage by the phase angle of pi by 2. அப்படின்னு கிடைக்கும்.